It's a math problem. Y'all know what to do, but the catch here, no calculator. Today we're looking at the distributive property. And we're going to be using this distributive property to simplify an expression. Remember that an expression is simply a mathematical statement without an equal sign. Let's take a look at what we are doing in order to find the answer to 5 times 17 without using a calculator. Now, most likely what you did was set it up like you would have done in elementary school. 17 times 5, you do 5 times 7 is 35, and then you'd bring down a 0, and then you do 5 times 1 is 5, and then you would add those guys together. 5 plus 0 is 5, 3 plus 5 is 8, and 85 is our winner. However, there is another way to think about this. We use this, what's called algorithm, this way of doing multiplication, but have you ever stopped and thought about why we've got it going that way? Well, let's check out something that might help us realize what's happening. 17, that's also 10 plus 7. Now 10 plus 7 is a less simple way of writing that, but it's kind of useful in this. If we think about taking, this is 5 times 17, well, taking 5 times 10 plus 7 should be the same thing. And there is a neat, nice fact with multiplication, that taking 5 times 10 plus 7, well, I can take the 5 times the 10, multiply those together, 5 times 10 is 50, and then I can take 5 times 7, multiply those together, and I get 50 plus 35, which is 85. Now, if you look carefully, you'll notice that's doing the exact same thing as that algorithm that we looked at before. But it's just a little easier to break down and see in your mind that if we take 17 and disassemble it into a 10 and a 7, 5 times 10, we know that, 50. 5 times 7, we know that one, 35, and then we just add them together. What we've seen here is, in fact, the distributive property. So the distributive property is a way of simplifying. Again, that just means making an expression easy to understand. And what this really is getting the core at, this right here where we say multiplication can be distributed over addition or subtraction, is a fancy way of saying in words what we just saw right there. If I have multiplication and it's being multiplied over an addition or subtraction problem, doesn't matter if this is plus or minus, I can rewrite that as being 3 times 5, and then whatever this was, a plus sign here, and then 3 times 2, and so this is really just 15 plus 6, or 21. Now if I go ahead and add 5 plus 2, that's 7. 3 times 7 is obviously 21. So we can see that when I multiply this way versus adding and then multiplying, I get the same answer. So this distributive property where I can multiply by each one of those is actually a tool that we can use to help simplify a problem. For example, this expression, 4 times x minus 9. This expression does contain a variable, and I'll never know what that variable is. It's not an equation. I can't solve it to figure out what the variable is, but I sure can take that 4 and multiply it by the x, and then I can take the 4 and multiply it by the 9 with that subtraction sign still there. 4 times x I just write as 4x. 4 times 9 would be 36. And now I've taken what was a more complicated expression and simplified it down into just a linear term and a constant term. And so this is why we call it simplification. There are some arguments that maybe this would be easier to see in some environments. However, this is what I want if I ask you to simplify something with the distributive property inherent to it. And notice that we can identify the distributive property by these parentheses. That's pretty much always going to be there. So in example 2, I have negative 3 times 5x plus 2. the negative 3 is being multiplied by everything inside those parentheses. So I can rewrite it as negative 3 times 5x plus negative 3 times 2. Well, negative 3 times 5x, I just multiply the coefficients and I get negative 15x plus negative 3 times 2 is negative 6. But we remember that if we add a negative, that's the same thing as subtracting. So when I simplify, I'm going to simplify that into negative 15x minus 6. So I've now taken this, multiplied the negative 3 by each part, write that out, that's very important, and simplify it down and see what I end up with. There is a situation that causes a lot of misunderstanding. If the number being distributed on the outside of the parentheses is a negative 1, the 1 is not written. For instance, if I wanted to write out negative 1 distributed through 2 plus 4, I would not actually write the 1. I would just write that as negative parentheses 2 plus 4. And it's understood that that 1 is there, even though it's not written. So to look at an example, if we're asked to simplify negative 2x plus 3, that is the same as if that were a negative 1. In fact, it's just like saying negative 1 times 2x plus negative 1 times 3. This would leave me with negative 2x plus negative 3 plus a minus. I know that's the same thing as subtracting. And so I can distribute a negative sign through the parentheses by understanding that there could be a 1 there. Sometimes we're just asked to simplify and nothing else, like there's no further direction. It doesn't say simplify by combining like terms. It doesn't say simplify by using the distributive property. We have to use our heads and understand what that means. Those are the two ways that we've learned to simplify, so it's possible that we have to do both. If that is the case, make sure you do the distributive property first. So here I've got negative 3x plus, and now what I'm going to do is distribute that 5 first thing through the problem. 5 times 2x is 10x plus 5 times 4, which is 20. So I distributed the 5. Again, 5 times 2x is 10x. 5 times 4 is 20. Now I can combine like terms. The first term I have is linear in x, so I look for any other linear x terms, and these two are like terms. They're both linear with x as the variable. So negative 3x plus 10x. Again, if you are ever even remotely unsure, go ahead and type that in and make sure that you know what's going on. So negative 3 plus 10 is going to be 7. So I would come over here and I would say 7x plus 20. That's now a linear term and a constant term. I cannot add those together, so I've simplified it. For this one, it's double duty. I will have to distribute twice and then combine like terms. So we begin here with the negative 3x minus 2, and for ease of understanding, I'm just going to copy the whole thing down again, and we distribute that negative through both, understanding that that is a negative 1. So negative 1 times 3x would be negative 3x, and then minus negative 1 times 2, which would be minus 2. And then over here, I'm going to say minus, and now I'm going to distribute that whole negative 4. This is very important. That can be thought of as a coefficient. Go ahead and take that negative sign with it. Negative 4 times 8 would be negative 32x. Then we just use that negative sign as the subtraction sign in between there. Negative 4 times 1 would be negative 4. So again, notice when I distributed that second negative, I took the negative as part of the coefficient, or from the part we're multiplying, excuse me, and then I just used the sign of that first term as the plus or minus sign in between there. So negative 4 times 8x gives me negative 32x. Now there are a couple things to simplify here. Negative and a positive and a negative. If we're subtracting a negative, that's the same thing as adding. And if we are adding a negative, that's the same thing as subtracting. So now I have all of this and I can combine like terms. I would take negative 3x and negative 32x, and combining those together I get negative 35x. And then I can take my constant terms, which are like terms, and add them together. 2 minus 4 would be negative 2. And now I have simplified that. So to recap, when we are simplifying, we have two ways of doing it. We can do distributive property and we can do combining like terms. The distributive property is when I can take something that is multiplied by something in parentheses and multiply everything that's added or subtracted inside there by what's on the outside. For instance, here I can take that negative 1 on the outside and I would multiply it by the 3x, and then I would take that negative 1 and multiply it by the 5. And then I would take that 2 and multiply it by the 4x. And then I would take that 2 and multiply it by the 7. So this 2 gets multiplied here and here. The negative 1 multiplied here and here. Now when I finish all that out, I get negative 3x plus a negative 5, so that's minus 5, plus 8x minus 14. Once I've distributed, I can then combine like terms. A negative 3x and a plus 8x would be positive 5x. And my constant terms, negative 5 and negative 14. So negative 5 minus 14 would be negative 19. Consult your calculator if you need. And that is how we distribute.